In this podcast, we're going to talk about how to figure out the formula of a hydrate. And what a hydrate is a compound that has water trapped inside. And it always traps exactly the same number of waters, and we are going to figure out how many waters. So we're going to figure out what X is here. So a hydrate is a solid ionic compound with a specific number of water molecules trapped inside the lattice structure. And they have the general formula the ionic compound formula, however we'd normally write it, and then this little dot symbol, which is not multiplication, and then a specific number of waters. It is almost always a whole number. It could be a 1, a 2, a 3. It commonly goes up to 12. Sometimes you get a half here, a 1/2, but not very common, and we're not going to see any fractions. All of our x's are going to be whole numbers. There is no way to predict it on paper. You have to do experiments in the laboratory to figure out the number of waters. So when you heat it up, the water is released, and then you can calculate the number of moles of water that was lost. So for example, blue vitriol, which is a compound, which is a hydrate, it has water trapped inside. It's copper sulfate. That is 63% copper sulfate and 36.06% water. So again, because we have percents, we are going to assume 100 grams. So 63.94 grams of copper sulfate, 36.06 grams of water. Before we get started, you want to figure out the molar mass of your compound, copper 2-sulfate 159.55, and then the molar mass of water. Water is H2O. It is 18.02 grams per mole. So we're going to assume 100 grams to change our percent symbols to grams, and then we're going to go from, we're going to calculate the number of moles. So for copper sulfate, we're not doing each element separately. We have the compound. So we're going to keep the compound together. That's the grams of compound. That's its molar mass, 159.55, divide by molar mass, and we get the number of moles of copper sulfate. Now we're going to do the same to water. Got the grams of water, 36.06, divided by its molar mass, 1.998 moles of water. Again, do not round in the middle. Keep at least 4 sig figs for all of your numbers. And then, again, we're going to figure out which number is the smallest. In this case, it's 0.4, and divide by that smaller number. Okay, when we divide both numbers by 0.4008, we get 1 for copper sulfate, and we get a number that's really close to 5 for water, which means there are 5 waters for every 1 copper sulfate. So therefore, the formula is CuSO4 complexed with 5H2O. To name these, we name the number of hydrates, and we use the Greek prefixes like we did for covalent compounds. 5 is penta. So this is going to be copper sulfate pentahydrate. Okay, work through the next one. It's called Glauber's salt, and it has the following formula. It's sodium sulfate, 44%, and then 55% water. So figure out the formula, how many waters are there for each compound, and then we're going to name it with the number of hydrates. Okay, so because we have percent data, we're going to do what we did before, change the percent to a gram, assume that we have 100 grams. take the grams, divide by the molar mass, convert to moles for both sodium sulfate and for water. Take the grams of water, divide by the molar mass of water, and that gives us the moles of water. Look at both of these numbers, pick the one that's smaller, 0.3106, divide both of them by that smaller number, and you get a 1 and a 9.9, and 9.9 rounds to 10. So the formula is 1 sodium sulfate, Na2SO4, complexed with 10 waters. So this is going to be sodium sulfate decahydrate, because deca means 10. Okay, the next question is magnesium sulfate. Here, instead of percents, we've got some lab data. So we have 1.687 grams of hydrate. That's what the mass is before we've gotten rid of the water. And then when it's heated and the water leaves, this is the mass of magnesium sulfate that's left. So the difference between these two numbers is going to be the mass of water. We cannot put the water on a scale because the water evaporates, but we can measure the difference and calculate the mass of water. So magnesium sulfate, we know from our question, is 0.824 grams. The water that's lost is our starting mass, which is the mass of the hydrate. Subtract the mass of the magnesium sulfate, and that gives us 0.863 grams of water that was lost. So for our calculations, we're going to use mass of magnesium sulfate all by itself and mass of water all by itself. Convert these to moles and figure out what the mole ratio is. Okay, so magnesium sulfate, grams, divide by molar mass, calculate the moles. Water, start with grams, divide by molar mass, and calculate moles. Notice because we had real live lab data here, the numbers are really, really tiny because the grams are a lot smaller, but we don't care about the numbers. All we care about is the ratio. So it doesn't matter if the numbers are small. Take the smaller number, 0.006849, divide them both by that number, and we get a 1 for magnesium sulfate and a 6.99, which rounds to a 7. That's for water. So the formula is MgSO4 complexed with 7 waters. The prefix for 7 is hepta. So this is magnesium sulfate heptahydrate. So make sure you get that in your notes. Last one is alum, aluminum sulfate hydrate. Pretty complicated formula. It's got potassium and aluminum and sulfate. So make sure that you are really careful when you calculate its molar mass. Again, we're given lab data. We've got 4.74 grams for the hydrate, which is everything together. And here we're told that it loses 2.16 grams of water. So we're given the mass of water, and the difference is going to be the mass of the aluminum sulfate. So that's going to be 4.74 grams, subtract 2.16 grams, and we'll get the grams of potassium aluminum sulfate. And then again, same thing, convert to moles and figure out what the ratio is. Turn off your video, work through the problem, and then turn it back on to check your work. So the subtraction, 4.74, subtract out the water and you get the grams of potassium aluminum sulfate. So that's going to be the first step. Okay, the next step is going to be to calculate the molar mass of both, take the grams, divide by molar mass, convert to moles. Again, the numbers are going to be really tiny because we have actual lab data, really small numbers of grams. Take the grams of water, divide by the molar mass of water, and get the moles of water. Look at both these numbers, subtract by whichever one is smaller, 0.00996, and you get a 1 and a 12. So the formula is KAlSO42 complexed with 12H2O. The symbol or the prefix, the Greek prefix for 12 is dodeca. So that's going to be potassium aluminum sulfate dodecahydrate. We don't usually go past 10, but this is that's the prefix for 12.